If you want to set up early, that's how you do it. Install Python, installed VSC, which is just a code editor. And the resources should be available on uwcs.co.uk. So we're going to get started with the slides, though. So 10 minutes for the intro, 40 minutes for the talk, although we'll have to probably skip through the talk pretty quickly because we started a bit late. And then the bulk of it is the workshop. So X-Soc Python is a collaboration between 3 societies. It's UWCS, Warwick AI, and the Warwick Coding Society. So we have representatives from all 3 of these societies. We have Warwick Coding there, and we have UWCS, and AI is somewhere. So this is just us shilling our society. We do courses, we do industry talks, we do all sorts of competitions as well. Warwick AI just does a bunch of stuff on AI. I don't think we have a representative to discuss it, but essentially they do code nights as well, which is their main thing. Do you want to come down and do Coding Soc?
Yeah, so I'm the president of Coding Society. This is Alex, the vice president. My name's Alfie, by the way. I think the events here are old. Are they? This slide hasn't been updated, right?
This is last year, yeah.
Yeah, so this is some of the stuff we did last year, but this year we're hosting on Tuesday an internships talk, which I think you should all come to if you're interested in kind of like hearing about what it would be like to have a career as a software engineer. But like generally we do everything to do with coding, whether that's kind of recreational or teaching and so on. So yeah, and on Sunday we book a football pitch every now and then. So 2 p.m. if you want to play some football this weekend. Yeah. Cool.
Okay, cool. Okay, so this is week 1, so we're going to be covering variables, data types, and exceptions. The slides are a bit messed up, but hopefully you can still kind of get the gist of what's being said. Yeah, good luck. Everyone can code, theoretically, so if you try your best, you should be okay. It's probably not going to be easy if this is your first time coding, but you'll probably have lots of fun. By the end of today, you'll know what all of these fun words mean, probably. Okay, so what is coding actually about? Coding is about making programs, in this case in the language Python, and they do some sort of computation. So usually this computation is for some sort of output. So it's producing usually a visual stimulus. And these are all the considerations we have for data and all of the operations. So mathematically, we understand the notion of a variable to be essentially something representing a value, right? So in this case, the variable x represents a numerical value. So it has a name and it has a value. So in this case, we're moving away from maths and we're discussing a more normal variable name, a more human name. So in this case, 38 is an integer. And there were, as we'll see, there were various different types of data that we can store using variables. So there's a lot of different variable names that you can come up with. And generally, the rule is that you start with a letter, and you can't start with illegal characters. You can't start with an underscore, for example. Actually, you can do that, but you can't start with a number. And you can't use any weird characters that you typically won't see, and you can't use things in Python that already have a name. You can also represent under spaces with dashes if you like. It just depends on the syntax that you prefer. So first we're covering print, which is just a function. Whenever you pass something inside of it, it outputs it to the terminal. Does anyone, so for this, we have a variable which is sneakily named 7, and we're printing the variable, but this will not print the name of the variable, this will print the value of the variable. So in this case, it prints 6, despite the fact that it is named 7, which is just confusing. So here's an example of chaining two functions together. So you can do multiple functions after another. You just type them after. So it will print 7 and 4 in that order. So print also has, it's not just a 2-argument function. It can go up to n arguments. If you have multiple variables, you can just plug in those variables into the print function, and it will print it separated by space. Oh, this is an example of redefining a variable. So you can change variables basically as you want in Python. In this case, they're being changed to another numeric variable, but in Python, you can change it to whatever type you'd like. So now we're going to discuss some basic operations on variables, besides reassigning them. So these are your basic arithmetic variable operations, that you may have to use. So there is a difference between floating points and integers. Integers are whole numbers. Floating points can be decimals. And when you are dividing numbers, you should be very careful because you can divide them to produce a floating number, such as in the above, where you retain all of the decimal stuff. But you can also do integer division, which you may remember from primary school, where you have a remainder and you have what's left. Oh, and these things explaining how the code actually works are called comments. So everything after the octothorpe or the hash isn't counted, and you generally want to use comments to make sure your code's readable. Because people won't understand, sometimes won't understand what your code does if you don't comment it. So you generally want to comment things even if you think they're simple. Yeah, so this is due to floating points being kind of imprecise due to the fact that we can't store infinite precision. So examples of using floats, you can use them pretty much as you would use integers. So the operator precedence is roughly similar to bidmass, but if you don't want to rely on learning the operator precedence, then you can basically ensure an operation happens first if you wrap it in brackets. So you can, in Python specifically, this does not apply to all languages. You can make your code a little bit shorter by writing plus equals to mean we're going to increment this variable by some other value, which in this case is stored in another variable. So task 1, 2, 3 in the workshop will cover these. So exceptions, you may also know them as errors. So when you're running a program, it may decide to suddenly stop due to some coding error. So there are a number of different ways your code can be wrong. Syntax, generally you won't have syntax errors if you use something like Visual Studio Code because it will tell you when you're wrong. But you can also have runtime errors, which generally your compiler, or interpreter in this case, will tell you when you're wrong. And logic errors are pretty much completely down to you. So we'll go through some examples here. Oh, there we go. So this is an example of a variable not being defined, and therefore the error is thrown and it's shown here. Don't worry too much about these kinds of errors because your interpreter should basically tell you where the error is, and it should be fairly simple for you to correct that. Even if you're an experienced programmer, you'll sometimes just slip up and make these errors. So now we're going to, so we've already covered different numeric data types. So we've covered integers, which are whole numbers, and we've covered floats, which are essentially decimal numbers. So now we're going to cover how you can store things like strings, things like text inside this data type called strings. A note on spacing, so spacing is not, so spacing is kind of arbitrary once you've written down something on the line, but in Python, you cannot just arbitrarily start lines with spaces, and the reason you can't just arbitrarily start lines with spaces is because that's reserved for some high-level structures, which we'll look at in later sessions. So here are some examples of some strings. Notice that you can declare strings with either single quotes or double quotes, and you can put basically whatever text you want inside there. So again, be careful with the order of operation because truth is being printed, the variable truth is being printed after the first print. So some common operations on strings. You don't need to know this, but the top operation is called concatenation. You can essentially think of it as just joining the two strings together, which is what it is. And that's denoted by a plus in Python. You cannot do it in the second case because of because you're trying to do it between a string and a number. So with the join operator, or plus with numbers, Python doesn't have an inbuilt way of dealing with that, so it throws a fit. Task 6 to 9 in the workshop covers these. So sometimes you might want to convert between types. So for example, you might want to convert between, you might want to convert a decimal to an integer, for example. And you might want to convert a string containing just a number to a number. So these are three functions that we'll use to achieve this. So here's an example of a piece of text which only contains a representation of an integer. If your text is some arbitrary piece of text and it's not a representation of a number, and you try to cast it, then it will produce an error. And here are some common examples of how we use int and float. So string can convert to both integer and, integer and float can convert to string basically regardless of the case. You can have any arbitrary number, and then you can convert it into a string by using the string function. Whereas string to integer and float, as we discussed earlier, can fail if it's not a proper representation of a number in a piece of text. So here are some pretty common examples of typecasting. Some of them are right, some of them are wrong. So this is an arbitrary piece of text, so it does fail because even though it says 6, Python doesn't have an inbuilt way of converting word representations, only numeric representations. Oh, niche thing, not niche, but the int fails in this case because it's expecting a float, really. It's expecting you to convert this to a float. So floats, since they're decimal numbers, they are essentially a bigger data type than integers. Integers can only contain integers, whereas floats can contain both integers and decimal numbers. So we call the typecast from integers to floats a widening conversion. So here's an example of an implicit conversion of floaty to a integer in this operation. A conversion of whole to a float in this operation. So we can see that whole is 7, and it's implicitly converted to 7.0, and then it is added to floaty. So this is a widening conversion. A float can also be converted to an integer, but it will lose the decimal information. So for example, E, when you convert this, it will completely cut off the decimal part. So this is also called a narrowing conversion. So right now, we've just kind of been covering the operations in Python, how to use variables to facilitate our programs, but we haven't actually made our programs do anything meaningful. We haven't had them actually receive input from a user. So we use the input function to receive data from the user through the command line. So this example, it will print what's your name : to the console, and then it will expect the user to provide some sort of input, and then it will save that input to the variable your name. Input always returns a string value, but you can convert this from a string to other things, as we saw earlier. So if the user, for example, passed the piece of text Bob, then Bob would be saved to your name, and then we could input it here. Recall that the plus is for joining text, so pretty useful. So your age, in its first assignment, it's a piece of text, so it's a string. But then we can convert your age to an integer. So programs, they do computation, and generally they have data, they manipulate the data, and then sometimes they will display the data to the user. They can also receive data through inputs, as we've seen. Okay, so now it's about time for the workshop section, which should be a little bit more exciting than listening to the presentation. So It's a Jupyter notebook, which is just a coding environment for Python and other languages as well. You'll open it with Visual Studio Code, which I mentioned earlier. It's just a code editor. It's kind of like Word, but with fancy coloring and a way to run things. This was on the slide at the start, but if you are having trouble installing Python, you go to the Python website, install this is outdated, but you can install the latest version. We are going to be using Python 3.8, but this will come as part of it. Make sure to add it to path, because otherwise it will be very hard to run Python. This is Visual Studio Code. You can get it from the Visual Studio Code website, visualstudio.com website, sorry. And then you'll kind of see a bunch of icons on the left, and the little square thing. If you click on that, that's the extensions tab, and install the Python extension pack. So this will give you highlighting of Python scripts, and also, yeah.
Which platform? Just first, do you want us to download the latest?
Yes, so it should be, the latest should work, but you can also install 3.10.7. I would recommend installing the latest simply because it's more useful. If there are any questions for later, you can scan the QR code, which might not work, but hopefully it still will. But if the barcode doesn't work, just go to uwcs.co.uk, and then you'll find the Discord link on there. Various channels that you can access there. Okay, and that concludes the talk.